Swayam Prabha. Digital India. Educated India.
Namaskar. You have stepped into a course that is going to change the way that you look at data. Not just how you analyze it, but also how you communicate it. My name is Nivid Desai. I serve as the Program Executive at Writing Studio IIT Gandhinagar. Welcome to Writing for Data Science. This course is at the intersection of analysis and communication. As all of us know, data analysis is not just about coding and models. It is about solving real-world problems. And that is exactly why every single thought that goes into solving those problems needs to be communicated. And not just to one audience, across multiple stakeholders. That is where this course comes in. This course prepares you with the foundations of writing, especially curated for data science. We will discuss audience analysis, critical thinking, logical reasoning, as well as storytelling that is native to data science. So join me on a journey at the intersection of numbers and narratives. I'll see you in class. Namaste, hello and welcome to Writing for Data Science. My name is Nivid Desai and we are on a journey to explore the interesting intersections of numbers and narratives. In the previous class, we looked at inductive and deductive reasoning in depth, and we left with a question that these are the correct ways of doing analysis. But what about someone making a mistake? What about somebody thinking in a wrong direction, coming up with a faulty conclusion? And that, in fact, is all too common. Everybody who is learning data science or data analysis is bound to make a mistake, because sometimes those mistakes are natural instincts and the logic does not follow through with our natural instincts. So we must keep a very keen eye on our natural instincts and how they are guiding us sometimes in wrong directions and what logic actually dictates us to do. So today, I want to introduce you to some common logical fallacies in data interpretation. What do we mean by logical fallacies? It is a technical term within reasoning, but fallacies just means mistakes. So what are the mistakes that people do while interpreting data on a logical level? Let's look at some of them today, their examples, and discuss how to avoid them in our day-to-day interpretation and analysis. So before we move forward, just a little brush up on logical fallacies. Logical fallacies are flaws in reasoning that can make your argument unsound or misleading, even if your data is correct. In data science, they often sneak into reports, presentations, dashboards, even visualizations, especially when the pressure is on to produce a clear story or support a decision. So, whenever you are under pressure to produce something, it is highly likely that we might slip and make a logical fallacy. Therefore, it is important that we keep our eyes and ears open and see where our intuition is guiding us and test whether it is the right direction or not. There is a very important reason why understanding logical fallacies matters. A fallacy in interpretation or presentation can lead to wrong conclusions, misguided actions, or loss of credibility as well. In the first lecture, we looked at the role of critical thinking and logical reasoning in making sure that our data was not misguided. But it also doesn't ensure us that if we use logical reasoning, that our data will necessarily be well guided. There are also common pitfalls within logical reasoning that we need to be aware about. For example, there is a claim that I want you to read. Churn decreased after the new dashboard was launched. So, the dashboard must be the reason. This is the natural progression of logic, but it might assume causation from sequence. What do we mean by that? I'll come to that in a minute. But here's something for you to reflect on before we move forward. Have you ever assumed something caused something else just because it happened earlier. Meaning, if point A is before point B, have you ever assumed that point A caused point B? There are a lot of idioms like this in our Indian languages. Think about them. They often talk about, for example, I am a Gujarati. So, there is an idiom in Gujarati that says, Kagnu besvu, dalnu padvu. That if a crow comes and sits on a tree, and if a branch breaks apart and falls from the tree, people often assume that it was the crow sitting which caused the branch to break and fall apart. This is a logical fallacy. Which one? I'll come to that in a minute. You can think of your example before we move forward. It is always fun thinking about how we commit logical fallacies even in our daily lives, right? And that's what leads me to the first logical fallacy that I want to share with you today. Post hoc, ergo propter hoc. Now I know all five of these words sometimes seem unfamiliar. This is in fact Latin. Post hoc, ergo propter hoc is Latin for after this, therefore because of this. Meaning, if something appears after something else, it naturally follows in our mind that the first thing must have caused the other thing. Remember, the crow sitting on the tree and the branch falling down. This assumes that because one event followed another, the first caused the second. Here's an example in data interpretation. Sales went up after the website redesign. So, the redesign caused the sales spike. Again, I understand if this is the intuitive way that we are thinking about our interpretation. Naturally, we might think that if one thing precedes the other, that must have caused the other thing. But maybe a seasonal promotion or a viral campaign happened at the same time, and that is what drew up the sales. Have you checked for those things? Have you checked for other factors affecting sales apart from the website redesign? It is important to check all of these in detail so that your logical interpretation is not faulty. Here's an exercise for you. You observe that bug reports dropped after a new version launch. Write two possible explanations, one that is a fallacy and one that includes other possibilities. So, I am asking you to commit a deliberate mistake. First, go by what your instinct tells you, and then create another logical loop for all the other possibilities that our instinct naturally does not gravitate towards. I will get back to you with the second logical fallacy very soon. The second and among the most important logical fallacies to look out for in data interpretation is correlation implies causation. Believing that because two variables move together, one causes the other. I've picked this one after the first one because the first is also about causation and this one is also about causation. Correlation means two variables moving forward in whichever direction together. However, it is an intuitive mistake that we often do to jump to the conclusion that because something is moving together, one thing is causing the other. For example, people who eat more ice cream also report higher sunburn rates. These are correlated, meaning the consumption of ice cream and the rate of sunburns will go up together. But the real cause is, that's right, summer, hot weather. People eat more ice cream because it is hot outside, and they go outside to eat ice cream, therefore, they have higher sunburn. So, there is a third factor. Both these variables are moving together, but neither is causing the other. Therefore, we must look out for things which are affecting the movement of variables without jumping to conclusions at the first instance. In data science, this may look something like customers who use chat support spend more money. But is the chat support making them spend more? Or are serious buyers more likely to need help? These are important questions to ask because the natural conclusion that we jump to with the first observation often misleads us, often misguides us, and ends up in faulty strategy that costs us money. So, do not make that mistake even if your gut instinct tells you to go to that conclusion immediately. Stay at a lower pace of thinking. We discussed that in the first lecture of this module, if you remember. A data scientist who is a critical thinker slows down their pace of thinking and asks why. They always resist the urge of arriving at the first and the quickest conclusion because there is a highly likely chance that the conclusion would be wrong. So, cultivate a slower pace of thinking. Go step by step. Check each variable for its different nuances, and that will ensure that you commit less likely mistakes. There is no guarantee that any data analyst can commit no mistakes. So the best we can do is cultivate a slower, more deliberate pace of thinking. Here's a reflection for you before we move forward. Why is it risky to confuse correlation with causation when recommending changes? I've given you a hint when we were discussing this, but why do you think is it risky to look at correlation and to immediately jump to a conclusion that this might be a causation? Think about from a data scientist's point of view who is making these recommendations, and think about the executive's point of view who is implementing these recommendations. And you might arrive at a clear understanding about why confusing correlation with causation is really dangerous. I'll get back to you with the third logical fallacy very soon. The third logical fallacy is all too common an indicator of lack of critical thinking abilities. This is not only common in data science, mind you, this is also common in our daily lives. Confirmation bias. Interpreting or seeking data that supports what you already believe, while ignoring any other evidence which may prove things otherwise. I know you are smiling. I know you've done this already. I know I have also done this. And every single person is privy to doing something like this on a daily basis. For example, a report that emphasizes that most high performing sales reps use CRM tools but ignores that many low performers also use them. This is because we are biased towards the use of CRM tools, so we only report that the high performing sales reps do it, while ignoring that the low performers also use them. This is confirmation bias. You have already made up your mind. You're already convinced in your mind that this is true, and you try to look for evidence that supports your preconceived notion. This leads to extremely faulty analysis, and we must be very careful not to commit this at every step. Here's an exercise to ensure that we don't do it. Imagine that you believe email campaigns are effective. How might confirmation bias show up in your data analysis? Think about it. If you believe that email campaigns are effective, which is a preconceived notion that you have developed in your mind, how will it seep into your data analysis? And then don't do it, because it is the wrong thing to do. Confirmation bias hurts us every day. Again, not only in data science, but also in our daily lives. Please be wary of this so we become better critical thinkers and ensure that the world around us, not just numbers but also narratives, become healthier and more nuanced. The next logical fallacy is cherry picking. It's a cute name, but it usually means selective evidence, meaning only showing data that supports your claim while ignoring data that contradicts it. So, if you are making a claim, you will only find selective data that necessarily proves what you are trying to say, while there exists data that contradicts what you are trying to say, but you are shoving it aside. You are ignoring it completely. And that is cherry picking. For example, our churn dropped 8% last month. This claim fails to mention that it spiked the month before. That is cherry picking, because you want to prove that the last month's churn drop was a higher significance than the previous month's churn spike. The churn spike contradicts your claim, but you are trying to shove it aside just to prove your point. It eventually catches up to you. It eventually starts showing in your analysis, and it starts coloring the recommendations and conclusions that will arise from your analysis. Here's why it matters. Cherry picking can mislead stakeholders and result in bad decisions, even if the data shown is factually correct. Of course, it will be correct. You are not tampering the data at any stage. You are only selecting data that matches the claim that you are already trying to make. So, the data might be factually correct, it just will not be complete. So, it may just be looking at the favorable reviews or the favorable data points while completely ignoring the contradiction. Before we move forward, it is important to stop for a moment and reflect on this question. Have you ever seen a graph or a report that seemed honest but was misleading because it left out important context? That may be a good example of cherry picking, and it will show you why cherry picking leads to a completely false picture of how the situation spans out. The next logical fallacy that I want to talk about is false dilemma. Dilemma means a confusion between two options specifically. This is also called the either or thinking, presenting a situation as if there are only two options when more than two options exist. This forces you to make the wrong choice. So, if you only bring up two options, your stakeholder is compelled to choose between only two options when more than two options would also exist. Again, this is not limited only to data science. We also do this in our daily lives. So, learning about these can actually enrich us as people, not just as data science communicators. So, here's an example in analysis. Either we invest in new features or we lose all our users. You see the ultimatum tone in this statement? It is giving you two options to choose from. Either invest in new features or you will lose all your users. This is a dangerous claim to make because maybe there's a third option. For example, improving existing features or adjusting the pricing model. But if somebody is trying to sell you the investment in new features, they will create this false dichotomy and they will lead you to make a rushed, mistaken decision. So look out for it. Anybody who is trying to persuade you into making a choice quickly often is misleading you in the wrong direction. And you also, my dear friend, don't commit this fallacy because it leads to completely misjudged conclusions and disastrous consequences in real life. So here's a quick exercise for you before we move on to the last logical fallacy of the day. Rewrite this statement to avoid a false dilemma thinking. We either retrain the model from scratch or accept its poor performance. This is offering you two choices and it is an ultimatum statement. However, try to see what other options and possibilities might arise from this situation. Write them down. It will help you break free from the ultimatum and urgency of a false dilemma thinking. The last logical fallacy that I want to talk about today is overgeneralization. This is also connected to inductive reasoning. Discover for yourself how. Drawing broad conclusion from too little data or limited evidence. See, it reminded you of inductive reasoning, didn't it? So, overgeneralization is an obvious offshoot of inductive reasoning. For example, two customers complained about the chatbot. Clearly, it's a bad feature. But only two customers did that. How can you make a universal assumption based on two customer complaints? So, arriving straight at that conclusion is faulty. Here's why it is dangerous. A few data points may not represent the full picture, especially in user feedback or early testing. So steer clear of overgeneralization. I know that if we are biased, if we already want to jump to a conclusion, this overgeneralization helps us reach there faster. But the whole point of developing a critical thinking outlook is that we should think slower. Try to ask why. Try to ask different questions that probe deeper into each claim being made. So you avoid all of these logical fallacies and arrive at a clear, comprehensive, and coherent analysis of the data in front of you. Fallacies are not writing errors. They are thinking errors. They are thinking shortcuts that we all fall into. None of us are proof from it. But in data science, the stakes are high. Fallacies can distort reality, it can erode trust, and it can lead to bad business decisions. Here is a checklist to avoid fallacies in data writing. Look at these questions to ensure that you are not falling into any of these common pitfalls. Am I confusing correlation with causation, which is the most common mistake? Am I ignoring other explanations? Did I leave out data that disagrees with me? Or am I being too confident with too little evidence? All of these questions will help you steer clear of any logical fallacy, and I hope that we develop this as a habit to be vigilant of our natural tendencies to arrive at a conclusion faster. I will keep reinstating this, I will keep reiterating this in every lecture. Think slower, ask more questions, arrive at better judgments, not faster judgments. Develop an intuition that helps you instead of misguiding you. All of this will be the desirable consequence of studying critical thinking and logical reasoning. That was it from my end for this lecture. We were discussing the common logical fallacies that arrive in data interpretation. And we also looked a little deeper in our own thinking to see whether we commit it on a daily basis or not. There are chances that we do, but it's all right. We now learn how to not commit them and why they are dangerous to commit. In the next class, we will look at more nuances in data science regarding critical thinking and logical reasoning. Until then, all the best, stay curious and keep learning. I'll see you in the next class. Thank you so much. Namaskar.